Welcome, ladies and gentlemen. Today I want to make a video about something that is very interesting. It's an idea for a program. Now this program I would like to develop it myself, but I do not have enough time to do so, and it will require a good amount of know-how to make it happen. Although I still think it's useful as an idea for me to share this so that you can think about this problem to solve. So the problem that I have right now is it has to do with 3D printing and the limitations of 3D printing, and I'd like to solve that by introducing a new program idea that is called Muralification. So how to turn an object into a mural. The reason why I'm interested in solving this is because of projects that I have at hand that encounter many flaws from 3D printing as a result of highly detailed parts. So we'll go over this in a minute. But the general perspective of the idea is about trying to turn a shape that is extremely fine and adapt it so that the 3D printer does not have an issue with printing it. So I have two objects here on my screen that you can see, and I'll show you the problem with those in a second. Now the first one on the left is a flawed model, and you will see it show the problems that I'm talking about. And the one on the right solves this issue within the same set of programs that I used to create those. So this was made through Marvel's Designer for the clothing, which is amazing. I recommend it strongly. It's a beautiful program. And then I passed them through Blender in order to get STLs. And those are the STLs that I got. So this is the first one well, actually it's number 3, and then this is number 6. I made a few different exports to try and figure out how to solve the issue I was having with this. So let's slice it now and see the issue that comes up. See, we got it sliced right here. We've got organic support. This is for an FDM printer, the Ender 3. So you can see here that the slicing program was not able to slice the thickness of the fabric for the first character because the fabric was too thin. And so that is the issue that I seek to solve. See, now the slicing program decided to discard most of the fabric, and so now we just have a figure without clothing. Now I did manage to do a bunch of tweaks to try and fix this. So you can see that on the right side the object or the character did have thickness to their clothing that was good enough for the slicing program to perceive it and then create the slicing pattern. So if we dissect it, now the printing settings are not optimized at the moment. But you can see here on the right that there's about a 2-wall thickness to the clothing fabric, so it does print. And you can see that on the left side there is simply no fabric because the mesh was too thin for the program to consider it in the G code. Okay, so this is an issue, and you can see here I'm printing these objects. They have a height of 174 millimeters. So these are quite big, right? 170 millimeters, like half a ruler or something like that. So it's quite big. Now the issue that I have with this is that I want to print them in much finer detail. So I'm talking about having these characters, instead of 170 millimeters, will be about maybe 50 millimeters. And that would be on the tall side. I'm more looking at something like 30 millimeters. The thing is, if I scale it down to 30 millimeters, even if I did solve the thickness problem here on the right, the scale factor will render this edit kind of useless because the overall shape will become too small for the printer to see it, and the same fault will appear on a smaller scale of that same quote-unquote fixed object. And so here's a question: how do you solve that? What if I want to make a mural with multiple different characters that have all the detail of this clothing fabric? Now I'm going to be confronted with the fact that these characters are going to be too small in order for the printer to be able to print the fabric detail. So how do you solve that? That's the problem. I'm going to show you here a picture of the project I have in mind for which I wish to solve it, which is this one here. This is a axe head that I wish to make out of 3D printing. More precisely, I wish to 3D print the head over here in 2 parts out of metal. But the tolerance of metal printing is up to 0.2 millimeters, and so it can express a lot of detail, but it cannot express the detail of the fabric without causing flaws, as you just saw. And so I have to fix this. So here is a little bit more of a zoom in on the detail of the head. You can see here that there is like kind of a painting or a mural inside of here that I wish to depict in 3D, like in relief. Like a vertical topology type of picture. Now these characters have different types of clothing. There's like a fort in the mountains, and up here there's 2 people like clergy and with a knight and a bird. Anyways, all these details are very fine, especially the end product. Like I said, the top or the height of these murals will be about 30 to 50 millimeters. So the characters are going to be exceedingly small. So that's going to cause a problem if I just use the same characters as just shown you before. So how do you solve this? Here is my perspective on this. It comes in the form of a program that I do not have time to write because I need dedication, effort, which I don't have, and so I'm sharing this problem so that perhaps you can help solve it. So here's how I would solve it if I had the time for it. So this program would be called Muralification, and I would use a skeletal metric approach to solve this problem. So I have here a few grids, a few different sizes of skeletal metrics. Here, this cube is 1 feet by 1 feet by 1 feet, 1 foot by 1 foot by 1 foot. Apologies for that. Or 2 cubes. So how can I use this to try and solve this problem? So if the problem here is that the thickness of the fabric is too thin for the printer to realize, then what I can do is I can create a system that will analyze the topology of a vertical plane from a distance so that it can measure a number of different distances at various different points in order to create a topological map of what I'm trying to draw in 3D, and then end up with a relief of those 3-dimensional characters. So it's a little bit complex, but here's how I would do it. So see here I have a basic cube. So I can assess the position of the cube, and then I can draw from the center a straight line until it collides with the character. So that would be an if function that would go through until it registers a distance where there is a collision with the object. Now this is a little bit difficult to hold on, I'm in the gap here, so that would be void. Let's just move those 2 objects here like this. Okay, so it would be based on the position of this cube. I can say that there is an you can call this plane here the origin or the center. So let's put a label here. That would be the measurement and then the position of the cube, which would be say 1 and 1. Or I can go right, so that would be this first cube, let's say. Okay, that's good. And then I would get a measurement in distance from that center, or a topological measurement. Actually, it's more like vertical or horizontal topological measurement. Okay, so this will give me a distance that I can then measure and see the distance here. So this measurement here would give me insight on the position of the fabric here relative to the center line of this skeletal metric grid. So from this, I can then transpose this distance those and this. I can then use this and copy the data to another plane or path or file path. Copy the same data here, and then what I get is the line that identifies the distance between this center and the mural. Now from this I can then use the end result of those many lines in order to recreate the topology of this object from a linear or frontal perspective. And so I can have this gathering of many different distances that will give me insight on the position of the mesh according to the fold of the fabric here. All these different points will give me different distances that I can then recreate in a two-dimensional fashion by relating those points. It will not be two-dimensional, but it will be a relief of the vertical perspective of that. Then what I can do is I can use this relief and I can draw. So let's go rectangle. Can draw a plane like this and then alter the position of the plane according to the distance input I got from this measuring system. Now understand that this is too much of a big grid, and see here I get only 2 measurements for the whole thing, but I can scale this down indefinitely until I get a point cloud like this, or even smaller. I can just keep on reducing its size. Right, so I can go here, duplicate this, and then scale it down, which can happen inside a single function. I can scale this down basically infinitely, and so here if I draw a straight line out of every point, so let's go here and add a line until I reach the object. Those should be components. I don't know whether or not yeah, so I created those in the rig. Now it's not working. I have to create it again, so let's try this again. Why is this not working? What's going on here? computer's not working. What's going on there? Okay, I got it. So let's go here. X3. So I can have this here, and then let's take this. Okay, so sorry for that. I got a little bit of a problem there. So if I take the same line and I extend it from here, then you can see I'm getting a whole lot of different lines here. And I can use this to analyze the different information I can get from this, and I can scale this infinitely small so that I get infinitely smaller space between my points, and so I can create a topological map of this object and thus create a mural. Now with this mural, there would be no gaps or no thinness to this clothing. It would be simply a relief of the form from the outside, so it would look the same, but it would not have the thickness issue of the fabric. Although that is useful in order to create the clothing and the way it ripples, when it comes to 3D printing, the thickness of that fabric creates difficulties. So that would be how to solve this with a program using skeletal metrics to create a mural out of these multiple poses. So thank you for listening, and I'll see you soon.